Hey guys, what's up? So today we're gonna do the LeetCode diary question, which today is this question. It's an array question, and so the question is really simple. It gives you two array, and then you want you to return the maximum length of subarray that appear in both array. And so something you need to notice is that the position might not be the same. So what it means is that like here you see the two position isn't the same, but still count as the same subarray as long as the sequence, the subarray is the same. So for this question, so my first mindset would be sort of so for first, like my idea for this question, I don't know which my idea it is, but like I was thinking use some sort of binary search. So as you can see here, the length one is the two lengths are both 1000, and then if you want to write a solution, have to be O n square. Or you can take O n square again. This will maybe work, but like it's not guaranteed. And so firstly, I was thinking like, oh, it have to be O n Rogan solution, right? If it's Rogan, then it's like you have to use binary search. And for my binary search idea, it's like, so I feel like it's pretty hard for you to match the length, but like if you fix the length, it will be easier to verify. What it means like, for like here it's the two subarray, right? And instead of searching the maximum length, I need to verify it such that if the length k subarray exists, so k can be any number between 0 to 1000, and in this case 0 to 5. And I sort of this way, but like I didn't sort of a good way to compare it in instant time, constant time, to like, because in order to make it work, it's like have to be log(n) times O(n), right? And for each individual element, I want to have O1 time to sort of verify it. And I didn't find a good way to do that. So this come to my second idea. My second idea would be sort of a lie to array. What that means is like we take array as two parallel array and they are not correlated with each other, and we just place it like in column form. So the two array would be look like this. And in each operation, we shift it. What I mean by shift it is sort of like this time I start with 0, index 0. We compare from 0 and 0, like both index start with 0. And second time, for my first subarray, I still start with 0, but for my second array, I start with index 1. And sort of like shifted the two array to find the maximum match. And in this case, the max match will be occurs at this scenario, which is the first subarray start with 0. Wait, let me think about it. Yeah, for the first subarray start with index 2, and for second subarray start with 0. And in this case, we can get the maximum subarray. And here is my solution. My solution is really simple. So I got two variables. One variable is length, and length is to tracking the current length, and also a maximum length, which is tracking the global maximum length. And another thing you need to notice is that like we need to give both separate chance to shift it. So we might start with shifting the first subarray to make it start with index 1, start with index 2, and etc. etc. And after that, we have to apply the same method for my second subarray, and this is how my algorithm work. This is my first for loop. This for loop will be like align with the first subarray, and then this for loop will align with second subarray, and I just use the maximum length to keep tracking the global maximum. And just standard stuff. For like here is the for loop is like if the two elements are the same, then I increment the length. Otherwise, I check if it's a maximum subarray, and then I also like reset the length to 0. And this is basically my solution, and it runs very fast. So let me submit. And it almost like running like the fastest. If you see the detail, it's running really fast. I'm actually surprised by my. I should wait. Okay. Oh, what? Okay, this is crazy. Oh, what? Oh, I think this guy uses some. So, for this question, I got another idea, which is banner search, right? And I'm thinking like, how do we do something such as verify each in? I mean, a fixed length subarray occurs in two index of subarray can be verified in all one time, and in this case we can do the whole operation finding the such that if the fixed length k subarray exists in both array in all n time, and in this case the whole algorithm will run in O log n log n time, and which is much better than my O(n) square solution. But haven't come up with a way to like so one way popped in my mind is to use a hash table, and for this hash table I just didn't think of a good way to do it, and maybe I should check out his solution and then have a look. So he's using onset rong as his hash table. Okay, that's pretty cool. And for I hashes, I'm not even sure what he's hashing about. So that's actually funny. Order set. Okay, I think he uses some of my idea. I mean, so check is exactly what I said. So it check it give you two vector and the fixed length. Only want to check if that exists. And here it's just using banner search, and it's pretty cool. Yeah, but like I don't get how it hash use p and no idea. Anyway, yeah, I think that's for today. That's like all I need to do for today. The code, and thank you for watching. Thank you guys.